Hello friends, today we are going to calculate the required load of the given code system in which the code is suspended at location A and B, and we know that as per the figure A and B is at the different level. Another point is given as the 300 Newton at location D while unknown weight at location C, and we have to find out this weight if the final position of the code is as shown in the figure. So the given figure is the final position in which if we observe the location D, then it is at 1.5 meter from A. If we observe the location B, which is 0.4 meter from location A, while point C is 0.4 plus 0.7, it means 1.1. So the location of C is 1.1 meter from the location A. Similarly, if we observing the point D and C, then the D point is at 1.5 and C point is at 1.1. It means the distance between C to D in vertical direction is total 1.5 minus 1.1. It means it is as a 0.4 meter between C to D point. Now horizontal distance between all these points is given as 3.6 from A to D, D to C as a 3.4 and C to B as a 2.4. Now using this distance we have to calculate the angle between the chords, and first we are going to assume the tension in chord as now first if we take the point D and if we take a horizontal line passing through point D, then the angle between horizontal line with the tension chord as a AD, if we take the tan theta or we assume that angle as a theta AD, then tan theta AD, which is equal to opposite side as a 1.5 and adjacent side as a 3.6. It means our angle with respect to AD or DA, which is 22.62 degree. So here the angle is 22.62 degree. Similarly, if we calculate the angle between DC and assuming this angle as a theta DC, then tan theta DC value, which is equal to opposite side as a 0.4 and adjacent side as a 3.4, which is equal to 6.71 degree. And again, if we going for the C to B location and if we take a horizontal angle between the C as a theta CB, then tan theta CB, which is equal to, now for location C to B, if we take a vertical drop, then the vertical drop value is 0.7, and so we have to take this 0.7 divided by 2.4, and by solving this value we will have theta CB as a 16.26 degree. Now using this angle, if we draw a free body diagram for location D, then if we enlarging this view, then the free body diagram is look like. Now we know that the 300 Newton is suspended at location D, angle is 6.71 for DC's chord and 22.62 for DA chord. Now if we take the total angle between TDA and 300, then the total angle is 90 plus 22.62. It means it is 112.62 degree. Now 300 and TDC or chord DC is 90 plus 6.71. It is 96.71 degree, and the rest value is total angle is 360. So 360 minus 112.62 minus 96.71, which is 150.67 degree. Now for this system, if we apply Lami's theorem, then the TDA divided by sine of opposite, it means 96.71, which is equal to 300 Newton load divided by sine of opposite as a 150.67, and for TDC divided by sine of 112.62 degree. Now for this similarity, if we take first similarity, then our tension in chord DA, which is equal to 300 divided by sine 150.67 degree into sine 96.71, and our value for tension in the chord DA, which is 608.25 Newton. Now for the second similarity, our value for chord DC, which is 300 by sine 150.67 into sine of 112.62, hence our value for tension in chord DC, which is 565.33 Newton. So according to this calculation, we have TAD value as a 608.25 Newton, while TCD value as a 565.33 Newton. Now going ahead for the point C, and if we draw a free body diagram for location C, then here the angle is theta CB, which is 16.26. For the tension chord of CB, W is unknown, and the TCD makes the angle with the horizontal as a theta DC, as if we draw a parallel line passing through location C, then pairing of these two is similar. So theta DC value is 6.71. So here our value is 6.71 with the horizontal for TDC, and our TDC value is 565.33 Newton. Now if we draw a enlarged view of location C, then it is as shown in the figure. Now observing the figure, the angle between W and TDC, which is total 90 minus 6.71, so it is as a 83.29 degree. Now for the TCB between W as a 90 plus 16.26, so it is 106.26, and the total value from TDC to chord CB TCB as a 360 minus 83.29 minus 106.26 as a 170.45 degree. 565.33 divided by sine of opposite angle as a 106.26, so which must be equal to W divided by sine of 170.45 and it is equal to TCB divided by sine of 83.29. Now using this similarity, taking first similarity, we will have the unknown weight W, which is equal to 565.33 into sine of 170.45 divided by sine of 106.26, and our value for the unknown weight W, which is 97.70 Newton. And if we take the second similarity, or we can say that the first and third one, then our TCB value is 565.33 into sine 83.29 divided by sine of 106.26. In chord C to B, our tension value is 584.8 85 Newton. So the value indicates that if we hang a 97.70 Newton load at location C, then the final position of chord is as shown in the figure as required. Thank you.